$13 billion. That is the price of the USS John F. Kennedy. For that kind of money, the American public expects something close to a sci-fi superweapon. Instead, the first ship of this class became a national embarrassment. Broken elevators, unreliable launch systems, endless delays. The USS Gerald R. Ford was labeled a floating disaster and a symbol of everything critics hate about Pentagon spending. One question dominated the debate. If the first one failed, why build another? Now the answer is here: CVN-79, the USS John F. Kennedy. This ship carries one of the most powerful names in American history, but it also carries a heavier burden: redemption. It was built to fix what went wrong, prove the technology works, and show that the American supercarrier is not obsolete. The question is simple, but brutal. Did the Navy actually fix the problems, or did it just build a larger target in the age of hypersonic missiles? Let's step onto the deck and judge it like the battlefield would. From the pier, the first reaction isn't fear, it's scale. The bow rises like a steel wall. The hull stretches so far that your eyes struggle to follow it. The flight deck covers more than 4 acres. This is not just a ship. It is sovereign American territory moving across the ocean. The USS John F. Kennedy is over 1,090 feet long and displaces close to 100,000 tons. It is an airfield that moves, survives storms, and absorbs the violent impact of landing aircraft every day for decades. And then there are the people. Nearly 5,000 sailors when fully deployed. Pilots, engineers, mechanics, doctors, security teams, and cooks. This is a small city at sea. But unlike a normal city, mistakes are unforgiving. On land, a delay is an inconvenience. On this deck, seconds can mean death. Everything runs on discipline, timing, and coordination that few civilian systems ever reach. What most people see is the flight deck. What they don't see is the city beneath it. The deck is only the roof. Below are fuel tanks, weapons magazines, data centers, desalination plants, workshops, and medical facilities. Miles of cables and pipes keep the ship alive long before it ever fights. But at the center of this entire system is one thing above all else: power. CVN-79 runs on 2 A1B nuclear reactors, but the reactors are only the source. The real story is electricity. This carrier was designed around the idea that modern warfare is electric. Sensors, radar, computers, communications, and future weapons all demand massive energy. Older carriers were built around steam. This one was built around electrons. That difference explains the price tag. For decades, U.S. carriers relied on steam catapults. They were powerful and reliable, but brutal. Steam launches aircraft like a hammer. It works, but it puts enormous stress on airframes and requires heavy piping, constant maintenance, and large crews. Steam also lacks precision. It struggles with lightweight drones and pushes heavy fighters to their limits. The USS John F. Kennedy was built to end the steam era. Instead of steam, it uses electromagnetic aircraft launch technology. Magnets and software replace pipes and pressure. Aircraft are accelerated smoothly, not violently. The jet still reaches launch speed in seconds, but the force is controlled. That means less damage, less maintenance, and longer aircraft life. It also means flexibility. The system can launch heavy fighters or lightweight drones by adjusting software, something steam could never do. Catching aircraft has also changed. Older systems relied on hydraulic arresting gear, strong but difficult to tune. The new system uses controlled electric energy absorption. Landings are smoother, safer, and easier on the aircraft. But here is the problem everyone remembers. On the USS Ford, these systems failed. They broke. They missed reliability targets. Critics laughed and called them unworkable. So why trust them now? Because Ship 1 finds the problems, Ship 2 fixes them. The John F. Kennedy benefits from years of hard lessons. Engineers had real failure data. Software was rewritten. Hardware was reinforced. Installation methods were improved. The Navy's goal is clear: increase aircraft launch and recovery speed far beyond older carriers. That is what justifies the cost. If this ship can generate aircraft faster and longer, it changes the fight. But a carrier is useless without its air wing. CVN-79 was built from the keel up to support fifth-generation warfare. Older carriers had to be modified to handle aircraft like the F-35C. This ship was designed for it from the start. The F-35C is not just a fighter, it is a flying sensor. It collects radar data, infrared signals, and electronic emissions, merges them into a single picture, and shares that information across the fleet. That turns the carrier into a command node, not just a launch platform. Seeing farther matters, but distance still rules the Pacific. Rival nations built long-range weapons to push carriers away from their shores. The Navy's answer is reach. The MQ-25 Stingray, an unmanned refueling aircraft. It extends the range of carrier fighters by hundreds of miles. That allows the carrier to stay farther from danger while still striking deep. What looks like a simple drone becomes a strategic multiplier. All of this fails if weapons cannot move fast enough. That is why one of the most important upgrades is also one of the least exciting. Weapons elevators. Older ships moved bombs slowly through complex routes. It created bottlenecks. CVN-79 uses advanced elevators designed for speed and automation. Faster rearming means higher sortie rates. In modern war, the side that can land, refuel, reload, and launch again, the fastest often wins. This turns the flight deck into something new. Not just a runway, but a factory. A factory that produces combat power at a rhythm few nations can match. Power means nothing without endurance. The Navy did not build the John F. Kennedy for one crisis. It built it for 50 years. That is the real gamble. Technology changes, threats evolve. Ships usually retire not because the hull fails, but because they run out of power, space, or cooling for new systems. CVN-79 was designed to avoid that fate. Its reactors produce far more electricity than it needs today. That excess is intentional. It leaves room for future radars, electronic warfare systems, and even directed energy weapons. The ship is a platform waiting for technologies that do not fully exist yet. There is also an industrial reason. Building a nuclear carrier is one of the most complex manufacturing tasks on Earth. If the U.S. stops building them, the workforce disappears, the supply chain collapses, and the skill is lost. CVN-79 keeps that capability alive. Critics argue the risk is still too high. One ship, $13 billion, hypersonic missiles, drone swarms. They say the carrier age is ending. The Navy's response is mobility. Fixed bases cannot move. Missile silos cannot move. A carrier can. It can reposition, adapt its air wing, and upgrade defenses. The bet is that movement and flexibility will always matter. At the end of the day, however, power is not only technical, it is psychological. In global politics, presence matters. Statements do not stop blockades. Meetings do not reopen sea lanes. A nuclear supercarrier on the horizon changes behavior instantly. You cannot send a virtual airfield into a crisis. You send steel. The name matters too. John F. Kennedy represents an era of American ambition. This ship carries that message forward, but its real strength is not technology. It is the crew. Thousands of sailors make this system work. Discipline, training, precision. That human element is the hardest thing for any rival to copy. So is the USS John F. Kennedy invincible? No, nothing is. But it was never built to be invincible. It was built to be undeniable. It is an answer to early failure, to rising competitors, and to claims that the supercarrier is finished. As long as oceans connect the world, the debate will continue. Is the supercarrier still the ultimate symbol of power or the ultimate target? That answer may define the next half-century of naval warfare.